Chapter 1. So we're kind of going back to the beginning, but the beginning really is an algebra review, specifically looking at functions, linear functions, and quadratic functions. So you're going to see a little bit of a review. This should be a review. So I'm going to go through it fairly quickly. What a function is, graph, math models, applications of some specific functions. Again, this should be stuff you know already, so I'm going to go through it like it's a quick review over this section. Alright, so first of all, the definition of a function. A function is a rule. So it's a rule that assigns every real number value, x, in the domain, a unique single real number, y, in the range. Alright, so we've got two variables in my function that we have involved here. We have the x variable and the y variable, and they're related by doing some math on them. Right? They're related in such a way that the y depends on what the x value is. Right? So y is a function of x, provided, and this is sort of the key that makes it a function, each input x, every time I plug in a single x value, I get out a single y value to pair with it. Right? So every x value I plug in, there is one and only one y value that comes out. And the y value depends on what x value I plug in. The rule is what you do. I take x, I multiply it by something, I add something to it, I square it, whatever, that would be the rules. Once I do all of my rules on my x value, I get a new value, and that single new value, that one and only one, that y value that pairs with my x value, is unique. Right? That makes it a function. So y depends on x. So y is always the dependent variable, x is always the independent variable, because I get to choose. Independent means I get to choose. I get to choose what x value to plug into my function. Y depends on what x value I choose. Alright, so is basically when we deal with functions, we're replacing the y part of an equation with a function expression. Alright, so instead of saying y equals some expression of x, we say f of x equals some expression of x. And it is read f of x. I take my function rules, the f rules, and I plug x into my function. Again, when you first introduce this function, you usually talk about it in terms of a machine. Alright, the function's the machine. X would be the raw materials that I put in the machine. The machine's going to do something to x, and then I get a single output once I apply my rules. Alright, so a single input with a single output. Alright, y again is the dependent, x is the independent. Alright, so again it's read f of x. We're going to understand domain and range basic forms. We're not going to go into the great detail like you would if you were in an algebra class. Again, you should have somewhere in an algebra class have talked about domain, somewhere in an algebra class going to talk about range. We're going to stick to it mostly in terms of applications. Applications will have certain domains. Applications will have certain ranges. Alright, so the domain is the set of all numbers that make my equation true. The set of all real number values that I can plug into the function to make it make sense, to make it make true. Alright, so again, I can only plug things, I can't, what we basically exclude is anything that's going to give me an error, division by zero, or some answer that doesn't make any sense, like imaginary numbers. Alright, so the domain is only those numbers that make the expression work, alright, in terms of our application. It's all of the independent variable parts. The range goes with the output. Right? It's all the real number values that can come out of my function. It's all the values my function solves for. Right? All of the outputs. All of the dependent variables. Right? And again, the range is the set of all of those. Right, we're going to look at functions, and there's three ways that you can represent function. That is sort of reverse of what we usually introduce here. Right, usually we start algebraically, graphically, and numerically kind of go hand in hand. Numerically means those are my numbers. So usually we do this in a table, right, where we set up, we have x values, and we're going to pair with them function values, y values. So we'd pick an x value, and we'd find the y value that goes with it. Right, and so that would be numerically. I found for these independent x values, I plug them in my function. These are the single y values that come with them. And then that kind of goes hand in hand graphically. these are the points on when we graph. We always graph thing in the xy plane, right? The x coordinate system, right? The y is the vertical axis, not asymptote, axes. X is the horizontal axis, right? We have our xy plane. That would be the y-axis. That would be the x-axis. Right, so when we plot points, we'll get graphs out. Alright, so we'll have, there's my y-axis, there's my x-axis. Alright, and so then that graph would represent some function. Alright, so graphically is when we, what a graph does, a graph represents all possible solutions. Right? A lot of functions, most functions, have infinitely many solutions. Right? There are infinitely many points. Right? A point would be an x and a y pair on this particular graph that I would found using a numerical table. And so this picture represents all of my possible solutions. I pull a point off of this curve, and I have a solution to my function. I have an x paired with a y value. All right, algebraically would be the expression, like f of x equals negative 2x squared plus 5x minus 3. That would be a quadratic case. And so algebraically, it's the equation. That's what the algebra is. It's the equation, which I use to find my numbers, which I use to then graph. All right, so those are the three ways that we typically represent functions. All right, we have a function equation, which then I can find a table of values. That's the numeric part. And again, they're infinitely many, so we only find a few. Since they're infinitely many, and I can't list infinitely many, well, what we do is the best thing we can do then is graph it. All right, and the graph represents the infinitely many solutions. And what the graph does, it tells us how the solutions are behaving. Are the solutions getting bigger, increasing? Are the solutions getting smaller, decreasing? Or how is it behaving? That's what the graph kind of tells us. All right, and so functions are what we're going to get into. We're going to look at some special, again, we're going to stick to some of the simplest cases. We're going to get into the common functions that we're going to deal with, which are lines and quadratics. All right, that's what we're going to get into in the next set. So it's just introducing you or reminding you of what functions are.